Okay guys, this is one of many videos that you'll see in APSTATS. This was our first quiz just to get your minds a little bit warmed up. Some of you did not do that, and you're going to get another chance today. The key thing, guys, is I can't actually teach every single problem when it comes to probability that's out there. I can just give you the basic ideas and concepts, and it's up to you to use your own thinking to figure these out. But enough said, let's get right to it. On this one, we're told that we have these cheerleaders and they're going to throw 50 t-shirts into the crowd. 50 t-shirts. Of these t-shirts, 10 are small, 15 medium, and the remainder are large or extra large. So the first thing you ought to think about is if I have 50 and I take away 10 small and I take away 15 medium, that leaves 25 that are large or extra large, right? And the question says, what's the probability that she will catch a t-shirt that is not small? Well, not small is the 15 medium and the 25 that are large or extra large. So what is probability is what you want. So I know I have 40 that are total, that are medium, large, or extra large. That's what I'm trying to get. They're not small, in other words, out of the 50. So that comes out to be, if you divide that, to 0.80 or 80%. And there's our answer. Now, let's say the question was, what was the probability that it was not medium? So, probability that it was not medium. I'm going to pause the video. I want you to pause the video and figure that out. So, hopefully, you came up with 70% or simply 0.7. Why? Because if we don't want medium, we want either the 10 small or the 25 that are large or extra large, right? And there's our answer. Okay, what about this problem here? Notice we're picking 2 students from these 5 students. There's only 5 members in this chess club, and they're selected at random to participate in this chess tournament. What is the probability that Adam and Ella will be selected? Well, the logic is simply this. If I'm picking 2 people, here's choice 1, here's choice 2, what's the chance that I pick Adam or Ella first? Well, there's 2 of them out of 5 members, right? Now, once one of them is selected, however, what's the chance that the second one is selected? Well, let's say it's Adam that was selected. What does that mean? Ella's 1 out of 4 remaining. Now, this is called conditional probability, guys. And what the secret of conditional probability is, you have to imagine, like I was explaining, take it one selection at a time and notice that the probability here changed after the first selection there. Okay, so now I'm going to give you, so the answer, getting ahead of myself, if we just times these together, that's how you combine probabilities, guys. I get 2 out of 20, which is simply 1 out of 10, or 0.1, or 10% chance. Okay? Now, let's say I told you that there was 7 members. Okay? What's the probability for Adam and Ella now? Well, hopefully you understand that the first chance, there's 2 of them out of 7 members now. And then understand that there's only 1 of them left out of 6 members on the second pick. So that works out to be 2 out of 42, which becomes 1 out of 21. Okay, let's go on to the next one. You're told that you're an online customer and about 15% of the callers have more than 8 minutes of wait time. The department conducted a simulation. They did it 1,000 times, 1,000 trials, and they collected all that information. And here's the key thing. They wanted to know the probabilities that a certain number of callers out of 10 callers. So basically they did every 10 calls and saw how many out of those 10 had to wait more than 8 minutes. And here was the histogram. None of the 10 happened about 18% of the time. One of those 10 calls had more than 8 minutes wait. That was about 34.5% of the time, and so on. So this is what we call a histogram, guys. All right? And hopefully you understand what that means. So in other words, 5 out of 10, half of the callers, 5 out of 10 callers, only about less than 1%, 0.8% did they have to wait more than 8 minutes. So that's a pretty good idea, right? So overall, this is pretty good results if you think about it in the real world. So, but that being said, here was our question. Based on the simulation, what's the probability at most 2? Well, the trick is, what does at most 2 means? At most 2 means 2 out of 10, 1 out of 10, or 0 out of 10, right? So if I want to know the probability that one of these is going to happen, we're just going to total them up. So I know that 2 out of 10 happened 0.284 times. We know that 0.345 happened, or I should say 1 out of 10 happened 0.345 times, and 0 out of 10, that means none of those 10 had to wait more than 8 minutes, which is a good thing, happened 0.181. So all I have to do is carefully add those together. I'm just checking, make sure I wrote the numbers down correctly. So unless I'm mistaken here, hopefully I can do my math correctly. I know that 0.810, or 81% of the time, I know 2, 1, or 0. At most 2 out of 10 has to wait more than 8 minutes. Okay, one more. So, now this one, guys, this is the star problem. Okay, this falls in the line of, I can't teach you every single thing exactly the way it's given. You have to learn to figure out problems on your own, and that's what this problem here is all about. So long story short, we're rolling 2 dice. We know one is red and one is green. It's a regular die where you either get a 1, 2, 3, 4, 5, or 6. Okay? We are going to subtract their differences. Notice there's order here. We're going to take whatever the red is and minus the green. We're going to do this 500 times. So it's simulated, as we say, 500 rolls of both dice at one time. Just roll the red and green together. Okay? These are also called trials. Get used to the lingo. Okay? So they had 500 trials here. And we were supposed to figure out what this distribution would look like. Well, what's the strategy here, guys, is you have to write and lay it out. And what I mean is this. I could have rolled a 1 and then a 1, red and green, right? Well, notice 1 minus 1 is 0. I also could have rolled a 1 and then the green was a 2. That means 1 minus 2 is negative 1. See how I basically have all 36 possible outcomes. This also may be referred to as the sample space of our results. Okay? But the key thing to understand is we could have rolled a 1 and a 6 and had a negative 5, or we could have rolled a 6 and a 1 and had a 5, and that was the max results. Right? And then what you want to do is maybe potentially put it on a dot plot to see how it all breaks down. So pause the video and see if you can't make a dot plot out of this information right now. Please try this, guys. Learn how to do dot plots. Understand the importance of looking at the whole sample space when doing a more complex problem like this. So I'm going to pause the video. I want you to try it. Guys, I did it real quick myself. Hopefully you got something that looks like this. Oh, wow. Notice how it looks sort of normal, right? Remember we talked about how normal curves happens a lot in real life. Here's a perfect example. Rolling 2 dice, we get, at a bare minimum, guys, we could say that this is symmetric, okay? But we also will say it's approximately. Get used to that word, approx or approximately normal. Because in real life, nothing is exactly certain things, right? More times than not, it's approximately or close to a certain thing. So approximately normal, symmetric. But the whole point, guys, is you had to pick the answer that went from 5 to -5, and the most common result should have been 0. Okay? And I don't have the exact choices here, but the idea was there was only one good solid choice that was symmetric or approximately normal that went from 5 to -5, and that was the one you were supposed to pick. So, guys, I hope you got something out of this video. I hope you watch and study this at least once or twice. Take notes on it. So I expect this to be notes in your notebook. Okay, notes in your notebook on this 4-question quiz that I just went over in detail. Okay, see you in class.